All right, folks. All right, folks. Let's try this again. I've changed some settings. Thank you to Ethan and Andrew and Josh for doing this. If anybody's still live, I'm going to send an email out now, and hopefully you're seeing this live. If you are, go ahead and comment because over here, whichever side of the screen it works for you. Um, I've got a comment section, so I'm going to use my other computer here to email y'all and say, hey, I'm going live. All right, just sent the email, so hopefully that works. Whoever is the one person who's looking at me right now. um, if you got questions, go ahead and ask them. So 2018 exam was pretty normal. I gave you a list of all the questions you should have been able to do. I've got this. So if you need me to write things out, I'll do that. Um, just wait and see if anybody has specific questions on that exam. Speaking of which, I should probably get it up here. I see 6, Ty, but that's not a question about the exam. All right, so anytime you're ready, anytime, since this is going to be crazy like this. Number one, are you serious? All right. Okay, what is a vector? Number one, the question asks, which combination correctly pairs a vector quantity with its corresponding unit? So, what are the vector quantities? Uh, choice number one, weight. Weight is a vector quantity because it's the force due to gravity, but kilograms are not the units for weight. Newtons would be. Choice number two, velocity is the vector quantity, and meters per second are the units for velocity. Speed is a scalar quantity. The velocity is the speed in a certain direction. Okay. So the correct choice, the reason that number two is correct is velocity is the vector, not speed. The last one, acceleration, the units are wrong. It's meters squared per second listed in the exam. All right. Meters per second squared for the units for acceleration. That work? Keep them coming, guys. Sorry for the delay this morning, but technology. Yeah. By the way, you see that behind me? Yes, I have read every book on that shelf, most of them twice, a bunch of them more than that. Those are all my favorite science fiction and fantasy books, plus a couple of reference books, plus the Bible, plus the Tao Te Ching, plus a whole bunch of other stuff. And that's my library, and it's actually smaller than I used to have. Yes, you can, Ty. Give me a break. You see how many books I read during the course of a school year. Boy, reading. All you got to do is have a book or Kindle, if you want, Nook or whatever they are. You can still read all of them in a lifetime. There's a lot of time in a lifetime. Okay, number 9. Golf club hits a stationary 0.05 kilogram golf ball with an average force of 5 times 10 to the 3 newtons, accelerating ball to a speed of 44 meters per second. What is the magnitude of the impulse imparted to the ball by the golf clubs? Impulse is force times time. It causes change in momentum. So, since you are given the mass of the golf ball and the fact that it's going from 0 to 44 meters per second, if you find your change in momentum, m times delta v, then you're going to find your impulse, which is force times time. They didn't give you force and time in the problem. So the impulse is mass times change in velocity. So it's 0.05 times 44 meters per second minus 0. So what is that? 40. I don't have my calculator handy. So I think it's choice 1. Did y'all get the answer key I sent out? Oh, the foibles of humanity. Scratching my nose, dealing with allergies. This is just like class. Got to wait for you to all quiet down. Check your email from yesterday. I think I attached it there. I don't know what sidewalk chalk gaming is. Yes, it's a PDF file. It's straight from the state ed website. Andrew, you're just as bad in chat as you are in class. Good to see so many people online. How's everybody doing in this time of COVID-19? I'm actually feeling guilty about leaving my house. Excellent, Ty. Excellent. Thank you. Yeah, did well. See those books? Yeah, I'm going through them again. Oh, that and playing some cross out. I miss track and field. I miss working with the kids. I miss y'all. I didn't think I'd do that, but yeah. Yeah, that's the big one. It's like I don't know if I'm going to be able to go play D&D tonight with my friends. Um, my one of my friends works at the Watervliet Arsenal, and I just heard this morning that two employees over there tested positive. So my friend who works there, I don't know if he's one of them, but because it's a big place. But he works at the Arsenal, so I don't know if I'm gonna chance it. That's a decision I have to make between now and about 6 p.m. More questions on the exam, please, folks. Don't tell me you're doing it right now. Dudes, you've had what? 3 days, 4 days? Well, Tuesday, Wednesday. All right, you had Tuesday and Wednesday to work on it. Uh, in a way, Tyler, I have to. Um, so this this is what I do. I help you guys. So don't worry about my sensitivities. Besides, it's fun working with you. Come on. All right. Tyler wants the other Tyler, Typhil, wants number 32. So let me check that out. 32. Spring has an unstretched length of 0.4 meters. The spring is stretched to a length of 0.6 meters when a 10 Newton weight is hung motionless from one end. The spring constant of this spring is okay. Let me write this one out. Just because I want to try this out. So we'll see what goes on here. The spring equation is F equals K times X. And what is X? X represents the elongation of the spring. So the elongation here is not 0.6 meters, it's 0.2. Why? Because it started at 0.4 and then got stretched to 0.6. Okay. So F is, how much was it? 10 newtons. Okay. What is that? 10 divided by 0.2. Yep. Choice four should be 50 newtons per meter. Does that work? Maybe I need a smaller whiteboard. Hey, are any of the, I know this is for the college physics guys, but any of the uh, Regis physics guys doing this one too right now? Josh, are you with me again? 39. Okay, V. 0.5 kilogram cart traveling to the right on a horizontal frictionless surface at 2.2 meters per second collides head on with a 0.8 kilogram traveling to the left at 1.1 meters per second. What is the magnitude of the total momentum of the two carts? Uh, the take the momentum of the cart going one way add it to the momentum of the cart going the other, but make sure you have the opposite sign for this one. So it'd be 0.5 times 2.2 plus 0.8 times 1.1. And so the magnitude is the difference between them. Okay, not both together, but the difference because they're traveling, one's traveling to the right, the other's traveling to the left, colliding head on. Okay. I don't have the answer key in front of me. And give me a minute here. I'm going to go get a calculator. I don't have a calculator handy. Ethan, where's your calculator? All right. Bye. Ah! Dun, 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 the tool of a physicist. Next one. All right, 2.2 plus point parentheses, clear it all. Could you use radians and stuff in question 44 instead of the centripetal equations? 44. Okay. Toy airplane flying a horizontal. Complete 10 complete circles in 30 seconds. If the radius of the path 0.4. You're adding a way too much of a complication. Andrew, I don't know if you can all see the chat window there. I guess you can. Could you use radians and stuff in questions 14? You could. I don't see why you'd need to. Okay. You're gonna end up kind of doing it anyway because 10 complete circles in 30 seconds means that's 1/3 of a circle per second. Yeah, you're good. Yeah, you got to do circumference of the circle for the distance around, and then divide that by the time, and then v squared over r to do the to find your solution there. So you could. Yeah, that was one where when I got to it and looked at it while the guys were doing the exam, I was like, uh-oh, I hope they remember how to do circles. Okay. This is another one where you're expected to know geometry for this. You're expected to know basic trig for this. So hopefully this doesn't surprise folks in the future. Yeah. So use circumference of the circle. Uh, um, multiply that by the time to make one circle, which would be 10 over 30. And then that'll give you your velocity. Square that, divide by the radius. I know if you did some algebra in there, you could get a single formula for it. What next? I might just stay on so that because we're coming up on 11 o'clock when I said the Regents guys would be coming in. So I might just stay on. If we repeat questions, we repeat questions. noticing that we're having questions on earlier in the year stuff. For the college physics guys, remember that the final exam won't cover the semester exam for Siena. Will not cover the Newtonian mechanics stuff. Um, it'll just cover from static electricity on. But the Regents exam, which who knows if we're going to be taking a Regents exam. The Regents exam is going to be coming up. And yeah, here we go. Amen to what, sister? Oh, I bet I know what it is. It's just chai, folks, and it's lukewarm at this point. Ugh. Right, no Newton stuff on the college physics exam. That's what I figured you were amening. Yep, yep, yep. '76 through '80, then '74. Let me do Andrews first, then I'll do Bobby's. Okay, '76 through '80, right at the end. Okay, base your answers to question 76 through 80 on the information below and on your knowledge of physics. On a flat level road, a 1,500 kilogram car travels around a curve having a constant radius of 45 meters. The centrifugal acceleration of the car has a constant magnitude of 3.2 meters per second squared. 76, 77. The reason they do that way is because on my scoring thing, 76 is you get 1 point for correctly choosing an equation that would solve the problem and substituting in with units, which is why I've been getting on you about it. And then 2 is correct solution with correct units. Okay. So 76, 77, calculate the car's speed as it travels around the curve. Since you know the radius and since you know the acceleration, the centripetal acceleration, use A equals V squared over R. Let me do the equation over here. Uh, 3.2 and 45. Oh, 3.2 times 45. Answer. Here, square root. Answer. Okay. Okay, your solution. All right, you see how that works? 76, A equals V squared over R. If you do the algebra, V equals radical AC times R, and then your substitution. That gets you 1 point. All of that gets you 1 point. And then the correct answer with the correct units gets you the second point. That's why it's listed 77, 76, 77 that way. Okay. 78. Determine the magnitude of the centripetal force acting on the car. That's F equals ma. Force equals mass times the centripetal acceleration. Okay. So 1500 times 3.2, whatever that works out to. What force provides centripetal force needed for the car to travel around the curve? This, notice that they give you a space to write on the answer key, okay? And it has to be a complete sentence, all right? With that said, we were accepting the word friction as a one-word sentence answer in the past. It's crazy. And 80, describe what happens to the magnitude of the centripetal force on the car as it travels around the car if the speed of the car decreases. Uh, F equals mv squared over r. It's a squared relationship. So as the speed decreases, the force, the centripetal force, is going to decrease by the square of the decrease in speed. Or if you happen to know the force that's going on, you know the change in force, take the square root of that. That's going to be your change in speed. Okay. Let's see here. Whole bunch of people have weighed in, so hang on. Going back up. Set. Did I answer 76 through 77? Okay. Oh, I see a never mind on 74. Maddie, that's not nice. Okay. And somebody had diarrhea of the typing fingers. Well, I'm just going to keep going right here. So, you know, yeah, if you sign on at 11, we can keep going. Since we're both doing the 2018 Regents exam, if you want to go back through and look at stuff, you're welcome to. All right. Um, yes, Carter. Yes, Maddie. It's one thing doing it in the classroom, it's another thing doing it live out here in public. And believe it or not, this is public. oh, oh, the things I had to go through to get this live stream going. Blech. And again, thank you to Andrew. He was first. Thank you to Josh Bulmer. He was second. And thank you to Ethan Brown. The three of you all necessary things that I had to do to get this thing back up and going. So good job, you three. All right. And thank you to everybody who's online now. Geez. I see 19, which would mean my whole college physics class. But then I'm also seeing a couple other folks like Will and yay, Cyberbully. Oh God. You guys are terrible. Ah, and that's why I love you. Okay, let's go back to the questions. Refocus. Oh my God, this is like classroom. Oh my God, I can hear you yelling at each other. Oh, except this time it's not Tyler. Tyler's quiet in the back now. It's Andrew and Maddie. Whoever thought Maddie'd be doing it? And I'm naming names. Oh my goodness, I didn't realize I looked so goofy with this. My goodness. What? You guys need to tell me how goofy I look when I make my faces at you. Must not have been my group chat because I wasn't doing that. Questions on the exam, folks. Otherwise, I'll shut this down and we'll go to the Regents guys. Actually, if the Regents guys are signing in, go ahead and ask your exam questions, please. How many of you, like me, have multiple windows open? I've got two computers going. Yeah, the one over here got the exam on it. It's got my email. See if anybody's sending me emails. 32. Okay, we did this one a little earlier, Josh, but that's okay. Again, I'm going to rewrite it. I don't know if you can back up the stream to see it, but that would be too much of an issue. The key here is, what is elongation? All right, so F equals K times X. X equals 0.6 meters minus 0.4 meters. So X equals 0.2 meters. All right. And that was the thing for the problem. The X is how far the spring stretches. If you use 0.6, you would have gotten one of the other choices. You needed to use 0.2 for the distance of elongation. Okay. $43. Okay, the diagram below represents a 3 ohm resistor connected to a 12-volt battery. Meters X and Y are correctly connected to the circuit. What are the readings on the meters? Okay, this is something that the Regents class hasn't covered yet with circuits, but the college physics have. Okay. Um, you're welcome, Andrew. Have a good one. Um, uh, Voltmeters are always connected in parallel. Now think about that. What's the property of a parallel connection? All resistors, when you connect them in parallel, have the same voltage across them as long as they're in parallel branches to each other and they're only connected to the source. Okay. In the same way, if you connect the voltmeter in parallel, it measures the voltage of the branch that it's connected to. So meter Y is the voltmeter. Ammeters need to be connected in series to what they're measuring because they have to experience the same current as the branch that they're measuring. Okay, so meter X would be the current or the ammeter, meter Y would be the voltmeter, and so the correct choice here, the current would be I equals V over R, so the current would be 4 amps and the voltage would be 12 volts. Okay, so choice 4 on that. All right. So I'm going to do a separate live stream for both classes. I'm going to do it later today. I'll send you out an email with the streams about the new information that you're going to be getting. I'll also be emailing everybody all of the information for that. Okay, so that's for me for later today and for you to look at, so that Monday, Monday, we can come back and I'll live stream chat for that. Okay, so I got my work cut out for me for you guys today. 13, Ethan. Okay. A charged particle is located in an electric field where the magnitude of the electric field strength is 2 times 10 to the 3 newtons per coulomb. If the magnitude of the electrostatic force exerted on the charge is 3 times 10 to the minus 3 newtons, what is the charge of the particle? Let me do this on the board. Use the E equals Fe over Q equation. Over, what's the 2 times 10 to the 3? Oh, yeah, it's 1.5 times 10 to the minus 6. My bad. Okay. But do you see how to do it? Yeah, I thought the there, that's correct. Okay, circular motion. Which diagram represents the direction of the velocity v and acceleration of the a of a toy car as it moves clockwise, horizontal circular path at a constant speed? Okay. Choice 1 is the correct choice. The acceleration for something moving in a circle is always directed toward the center, thus the name centripetal acceleration. It's always perpendicular to the velocity. All right, Mag? I'm just going to stay on this, Maddie. So if we repeat, that's okay. Reinforcement is good. So go ahead with any of the college physics guys. If you want to stay on, you're welcome to. Um, um, Regents physics guys, if you're just coming online, cool. So go ahead and ask away, folks. 17. Where are we here? Come on. Okay, compared to the resistivity of a 0.4 meter length of 1 millimeter diameter copper wire at 0 degrees C, the resistivity of a 0.8 meter length of 1 millimeter diameter copper wire at 0 degrees C. Resistivity. Resistivity is the property of the material. Did the material change? No. Copper wire. All right. The resistance of the second length would be twice as much as the resistance of the first length. Okay, but the resistivity is a constant. It's that Greek letter rho in the R equals rho L over A equation, that doesn't change because it's copper wire. Temperature was the same. The only thing changed was length, but that's affecting resistance, not resistivity. Oops, sorry, Maddie. Yeah, they might be. But then again, it's you, Michael, Swanee, Josh, and Will are already on. Have a great one, Philip. See you Monday. You know, I don't know why they put the say something down here for me to chat in, except that at the top I was like, hey, ask questions. I look goofy. I can't believe how goofy I look. I think it's kind of cool, but still. And why didn't you tell me my nose was so huge? Any other questions? Regents guys, college physics guys, go ahead, fire them off. And this is the difficulty of drinking anything with a mustache like mine. You're constantly doing this. One of the reasons they were called soup strainers. Let me look at it. Yeah, that you have to use the resistivity equation. Let me write it up and I'll show you. Okay. Have a good one, Ethan. Thank you very much again. Thank you very much again for pointing out what I needed to do to get this to go live. Excellent. Okay, no worries, Maddie. Where are we here? Okay, so you got to use the information from the whole thing about the light bulb. Uh, Incandescent light uses a length of thin tungsten wires filament, part of the operating bulb that is light. One particular light bulb has a 0.22 meter length of tungsten wire used as filament. This tungsten wire filament has a resistance of 19 ohms at temperature of 20 degrees C. Tungsten filament has a resistance of 240 ohms when it's operated at a potential difference of 120 volts. Calculate cross-sectional area of the tungsten filament. So again, use the resistivity equation. And unfortunately, I don't have my handy dandy reference table on me, so I can't plug in the numbers. The one I would need is the squiggly P there, the row. But that's what you would do to solve 66 and 67. Okay. Um, 68, explain why the resistance of the tungsten filament increases when the bulb is operated compared to the resistance of the filament at 20 degrees C. Because when you run the current at 120 volts and 19 ohms, you get a very high current going through that filament, heats it up. Okay. The filament probably goes to a temperature a couple of hundred degrees C, and that's what causes the resistance to go from 19 ohms when it's cold, room temperature, to when it's hot at a couple of hundred degrees C. You end up with 240 ohms, and so the current goes down because of that. But it's enough to maintain that temperature, and that's why the filament glows, and you've got a light bulb. Okay. Um, 69 and 70, calculate the power of the light bulb when it's operated at a potential difference of 120 volts. P equals V squared over R. Okay. That's right on the reference table. Let's see here. So hopefully I answered your question, Will. Ethan, we'll see you later. Thank you. Maddie, I got it. Other Maddie, you're welcome. V, you're welcome. Okay, we're down to the Regents, guys. +1, and or maybe 2. So I hope we can continue on. Any questions? Any questions? Yes. Number 9. Any Beatles fans out there? Beatles, anyone? Old British band back when I was your age, they were the big thing. Okay, this is another one of those repeats. I answered this way back with the college physics guys, just kept going. Okay, so number 9, golf club hits a stationary, meaning 0 velocity, golf ball, 0.05 kilogram golf ball, with an average force of 5,000 newtons, or 5.0 times 10 to the 3 newtons, accelerating the ball to a speed of 444 meters per second. What is the magnitude of the impulse imparted to the ball by the golf club? Let me do this in the form of an equation. Remember, the definition of impulse is an unbalanced force applied for a period of time that causes a change in momentum. That's impulse. Okay. So on the reference table, on the formula sheet, we should have the following formula. So J is impulse. That equals force times time. And that equals change in momentum. But Mr. Welkley, we don't have any time given in the problem. Right. But we do have change in momentum. That's mass times the change in the velocity. So that would be 0.05 kilograms times 44 meters per second minus 0 meters per second. And I believe that works out to, 2.2 Newton seconds. So there you go with your solution for that. Does that help? If it weren't for the Beatles, we would not have a whole bunch of power bands that we had today. Let's put it this way: the Who and the Rolling Stones were the anti-Beatles of the day, especially the Who. Number nine. Did you ever listen to it backwards? It does sound like "Turn Me On, Dead Man." It's weird. All right, see you Monday, Will. Unless you want to rag on the Beatles some more. Swanee, you on? Anything else from the exam, guys? I think my son bugged out because he didn't want to hear me with my outbursts, or he didn't want to hear the physics. Yeah, this is all public. Oh no, it's in the public domain. Gotta watch myself. Are you guys doing the exam right now? Please. Oh, don't tell me you are. What? Are you all Snapchatting off to the side so that I can't hear you? Number 8, a projectile with a mass of m is fired with an initial horizontal velocity Vx from a height h above level ground. Which change would have resulted in a greater time of flight for the projectile? Okay, remember projectile motion, it goes out and down. Okay, changing the horizontal speed, if you launch it from the same height, it still falls the same amount of time no matter what. So changing horizontal speed doesn't change time of flight for any projectile motion. So the only thing that affects how long the flight is how high it was launched from. Okay, so which change would result in a greater time of flight, increasing the height to 2h. Okay. Got to go back all to the projectile motion stuff for that. Height determines time of flight. Height determines time of flight. So vertical component, obviously. All right, we're down to 5. Maddie, Will, Josh, Mike, Sarita. Sarita, are you there? Swanee. What is she out playing basketball? Shooting hoops in the driveway? I don't know about you folks, but I'm bored as heck. I've read my books, all of those behind me, and some of you may have heard. I've read all of them at least twice, some of them several more times than that. That's all my science fiction fantasy stuff behind me. Questions, questions, questions. Otherwise, we'll call it a day. And then I'm going to do some more um, videos for later. Uh, for you guys, for the Regents Physics guys, I'm going to go through compound circuits and circuit applications. In other words, why, Will, you had that question on the one earlier about ammeters and voltmeters. Um, uh, I'm going to do that for our future. Okay. Fortnite. Oh, I can see why, but Fortnite. Yeah, I've spent a lot of time playing Crossout. And I went back to Wolfenstein, New Colossus. I played through that like 2 or 3 times. Not this break, but overall. Questions on the exam? I bet. Yeah. I gotta watch Stranger Things season 2. Haven't even seen season 3 yet, but what you reading, Josh? Thank you, Michael. Okay. Have you all seen one that we are not back to school until April 2nd? That went out, I think, Tuesday. All right. So if you hadn't gotten that information, make sure you check the school website again. We are officially not back to school until April 2nd. Oh, cool. All quiet. Oh, that's a heavy book. Oof. Yes, Maddie, we'll be back. But I I imagine they're gonna shut us down through the vacation eventually. That's what I probably see happening. But I definitely see us coming back. Uh, you know, school's out forever. Was that Alice Cooper? Not yet. It's not, buddy. Not yet. I do. I do. If for no other reason than they got to give parents a break. All righty, so folks, if you don't mind, I'm gonna call this one, um, and please check your email later. I'm going to be sending out the notes as well as worksheets for compound circuits and circuit applications, meaning what's a voltmeter, what's an ammeter, what's a fuse, what's a circuit breaker, what's a ground fault interrupter. Bye bye, Maddie. And then Monday, we'll come back to this. I'll definitely not do, I will stop the college physics guys at about 10:50, take my break, and have a separate session for you because with them I'm going to be doing electromagnetism. Okay. Um, Folks, it's been real. Stay safe, stay healthy. Uh, your friendly heavy physics teacher is signing off.